From the last videos, we talked about how can we transfer from rectangular coordinate to polar coordinate. As we know, so for example, we have P, and then we have the X coordinate and then the Y coordinate. So instead of having that, we're having a P and an R and a theta. So that will be how far are we away from the origin and how elevated we are from the horizontal line. Alright. So now from that, so usually when we have a coordinate, rectangular coordinate system, we may have y equals some fx. So the y will become a dependent variable, and x will become an independent variable. But here we can have r equal to a function of theta. So r is a function of theta. So we have some interesting things going on. So instead of graphing it in the very in the traditional sense, like a rectangular point, we will have it in the polar system. So let's have an example. Here we have an example r equal to 2 plus sine cos sine theta. Alright. So how do we even start out with this one? Well, we always start with a coordinate first, right? Because anything start with a coordinate, we define the coordinate. So let's grab it. Let's have the coordinate. Alright. This may not be necessary in y and x, but we can intuitively thinking it is in y and an x coordinate, because eventually r is just, we know that y equal to r sine theta and x equal to r cosine theta. So we know that it will be related anyways. But we don't necessarily have to put y and x on the coordinate. Alright, so with that being said, how do we start? So we might say, well, okay, let's start with theta equals 0. Alright, so cosine 0 we know that is equal to 1. So 1 that's times 2, that's 2, 2 plus 2, that's 4. So we may define 1, 0. This is when at this point when the distance at a point is shrunk down to the origin, which is 0. Okay, so we know that 0, we define this 0, pi over 2, just like a circle, a unit circle coordinate. We have 0, pi over 2, we have pi, we have 3 pi over 2, and again, we have 2 pi here. So we go like this. Imagine there's like circle going on and on here, but we won't do that, just in case we don't want to confuse and sort of complicate our eyes. Alright, so we have sine when theta equal to 0, cosine is 1, 2 times 1 is 2, plus 2 is 4. 1, 2, 3, 4. So we start here. Alright. Alright, so we may start with something else. Let's start with pi over 4, which is 45 degrees. So we know the cosine 45 degrees, that is 1 over square root of 2. So that is less than 1. So we know that times 2 will be less than 2, plus 2 will be less than 4. So we know it will be less than 4, but it's about 10 over 7, so it will be 1.4 maybe, 1.4. Okay, so 3.4. Alright, so 1, 2, 3. Somewhere here, maybe here. So just a sketch, right? Alright, so with pi over 2, what we're going to do? Pi over 2, cosine pi over 2, that will be 0. Alright, so 0 times 2, that's 0 plus 2, that's 2. Alright, so we have it here, this angle that we defined earlier. How much are we elevated from the horizon? And then how far are we from the origin? So we are 2 units away from the origin. Alright, so we have something like this. Alright, so with pi, what happened to pi? Cosine pi, that is minus 1. Minus 1 times 2, that's minus 2, plus 2, that's 0, so we'll go back to here. And we know that cosine from pi over 2 to pi is negative, right? Because from the convention, that's all is positive, and sine is positive, tangent cos positive, cosine positive. And so here, this region, cosine is negative. So negative, we know the plus 2, it'll be less than 2. Alright? But we go like this gradually, right, from pi over 2 to pi, so we've got to be behaving like this. Alright? At pi over 2, what happened at pi over 2? We plugged it in, that's 0, that's 2. Right? Alright, so pi over 2, 2 units away from the region. It's still acting the same way. Okay. Well, what happened from 3 pi over 2 to 2 pi is that the cosine is positive. Therefore, we know that along the way that everything will be positive until we reach this point, right? And same thing here, positive. So we'll be reaching this point. All right. So someone might say this appears to be the Limacon without an inner loop. Well, what do you mean when you have a loop or without an inner loop or with an inner loop? When you have an inner loop, meaning there's some interval of theta belongs to some interval that you plug into this equation, you have the distance away from the origin become negative, meaning at what particular degree of elevation, instead of having a positive unit going that way away from the origin, you have it go in the other way. So that's why if you keep having it, having like that, you will have an inner loop. And we talk about more of that later on, but now we just consider this quite simple Limacon without inner loop. So that's how you grab it in the first hand. Alright, so how do we even try to correct this, see if what we're doing is correct? Well, we may try to think of this as an xy function, where y is a function of x. So let's try it. Alright. So we know that something like this. Alright. We might want to plot it in the rectangular way, right? Alright, so let's start it. Now at 0, we know that arc is 4, so let's just say 4. Here, we start here. Okay. We know that the graph of cosine looks something like this. Right? If it's going to be 1 revolution, it may go to that, right? So this is 1 revolution. So the graph of cosine might look like that. But how do we transfer this? Well, this is times 2, so we know the amplitude had to be twice as big, because we times it by 2, so every single point at that value being times up by 2, so the amplitude will be bigger. But then you plus the 2, meaning this whole graph is being raised up by 2 units, because you plus each point being raised up by 2 units, so the whole graph will be moved up by 2 units. All right. So it will work in the same principle. But we want to quite be exact so that we can transfer back to this and we can match this polar graph that we're doing. You have pi over 2, pi, you have 3 pi over 2, and then we may have 2 pi. Alright, so here we graph some of the major points first so that we we'll know where the frame is. So here we have 4, that's 0, and at pi over 2, we said that the cosine partial is 0 plus 2, that's 2. So we know that 1 and 2 is right here. And then at pi, this is minus 1, so it becomes 0, so it becomes here. And then that's the least that's the least value you can get, right? Because cosine is between minus 1 and 1. Minus 1 and plus 1. Between those two values. So there's no way that this will be less than 0 because you have 2 here, right? And we may, later on, we may generalize some function when we have r equal to a plus or minus b cosine theta, and depends on the b and the a. If b is less than a, there's no inner loop. If b is bigger than a, however, we will have some inner loop. Alright? So here we have b equal to a, so we won't have an inner loop. We just have this. So that's just the first analysis of how we may predict the graph going to be. Alright, so we have this at pi is 0, at 3 pi over 2 is equal to 2 units, right? Cosine pi over 2, that's 0 plus 2, is 2. Right? At 2 pi, it goes back to 4. Alright? Well, we know the cosine graph look like that, so it just being raised up by 2 and the magnitude being times up by 2, so you know that the median, the graph will be at value 2, so you know that where it will twist and turn. So we look like this. So that's how the graph would look. If we transfer from this rectangular to a polar graph, all right? So we can might try to pinpoint and try to match this, see if it works. So at 4, it's right here. You see, I get down, the magnitude of r gets smaller and smaller and smaller and smaller until it reaches 2 here. Reaches 2 here at pi over 2, which is here. Alright, so it gets smaller, 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 smaller until here, get to 0 here. Alright, so from here, they start being raised up. It's getting bigger. Right, the magnitude of r away, the distance away from the origin is getting bigger. So you see, if you were to draw a line here, the distance away, so getting bigger, 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 bigger. Get into the biggest point with the largest value, the greatest value of 2 pi again at 4. So get to this point again. Alright, so we know that we're doing the correct way. Alright, so this is how you would translate back and forth, how you graph a polar function, r equal to f theta, at a polar coordinate, and here is the rectangular coordinate. This is how you would do it. Thank you very much.
We don't.